Welcome back to the next section of Chapter 7. This one's on the properties of logarithms. Last time we had an introduction to what a logarithm is. Now we're going to look more about what they do, how we use them, things like that. This is going to be another more conceptual section. Then we'll take the test on this part of the chapter that remembers no calculators, and we'll see how we can do stuff without calculators today. And then when we come back after the final into section 5, we'll be doing more computational stuff using logarithms and exponential functions and things like that. So let's have a look and see what we're doing. The first thing I want to look at, well, the learning targets. Obviously, I can use properties to simplify logarithmic expressions, and I can translate between logarithms in any base. So we're going to be changing bases, and we're going to be simplifying expressions using the properties we're going to look at. So now, after the obvious learning targets, the first thing I want to look at is a little bit of review of exponential properties. So, a couple things. If we, when we multiply two things together with the same base, what do we do with the exponents? We add them. So we're multiplying two things, we add the exponents. X squared times x cubed is x to the 5th. Likewise, if we're dividing two things, we're going to subtract the exponents. So x to the 7th divided by x cubed, 7 minus 3, would be x to the 4th. And then finally, a power of a power. If we have x squared cubed, we end up multiplying those two exponents to get x to the 6th. Being that logarithms are the inverse of exponential functions, the properties of logarithms are going to match these fairly well. So I wanted to get these on the screen first. So now let's look at some properties of logs. The first one we're going to look at is the product property of logs. So what the product property says is if we have a log of two things multiplied together, we can split that up and add them. Notice exponents, we had two things, means we add the exponents. Remember, the log is the exponent. So this is an exponent plus an exponent. That's how it kind of translates. So how could we possibly use these? Well, we can split things up, just like it says. Log base 3 of 9x, we can split that into log base 3 of 9 plus log base 3 of x. And then log base 3 of 9, 3 to the what power equals 9? That'd be 3 squared. So we get 2 plus log base 3 of x. And this is as simplified as we can get that. This isn't going to change. We can also use this property to go backwards. If we're starting out with two things being added, log base 8 of 4 plus log base 8 of 16. Well, 8 to the what power equals 4? That's a tough one. It turns out it's 2/3. We'll actually see that a little bit later today. And then 8 to the what power equals 16. It's 4/3. Again, we'll see that a little bit later. But using this property, we can combine that. Log base 8 of 4 times 16. 4 times 16 is 64. Now 8 to the what power equals 64? 2. So we were able to take this problem that otherwise we wouldn't be able to do and simplify it really easily. And notice this really doesn't take a calculator. 4 times 16 might be a little bit tricky, but seriously, if you had to, you could do that. So that's the product property. We can use it to split it up, and we can use it to combine it. What the product property does not say, and this is a big mistake. I wanted to write it down, put a big X through it, but the trouble is when you write it down, people remember that, and they don't remember the X. So I'm going to speak it. If this was m plus n inside the log, that does not mean you can split it up and multiply. If you have addition inside the log, you cannot do anything with it. I will repeat. If you have addition inside the log, you cannot do anything with it, at least not yet. So the next property is going to be the quotient property of logs. Well, that means when so here we had multiplication, now we're going to be dividing two things. With multiplication, we added, so with division, we're going to subtract. It works exactly the same as these guys. So let's look at an example. Log base 1.5 of 6.75 equals log base 1.5 of 2. Let's see, 1.5 to what power equals 6.75? Nothing's coming to mind. I mean, there might be a power there, but 1.5 to what power equals 2? That's not going to be anything. So we can combine them. When we combine, we're going to divide. 6.75 divided by 2 is 3.375. Aha, well now 1.5 to what power equals 3.375? If it's not coming to mind right away, you can use a calculator on this one. 1.5 times 1.5 does not equal 3.375, but equals 2.25. But times another 1.5 will equal 3.375. So that was 3 1.5s. So it'd be 1.5 to the third equals 3.375. You wouldn't get a problem quite like this on the test without calculators, because it would be a little bit more than I would ask. I'd be testing your computational skills as opposed to do you know the property. But it could be something like log base 3 of 18 minus log base 3 of 2. Combine it, you get 18 divided by 2 is 9. Then log base 3 of 9, 3 to the second power equals 9. So you'd be able to do it kind of like this one. Let's see, next property is the power property of logs. So we're going to have something to a power. And what we're able to do when we have something to a power inside the logs is we are able to bring that power out in front and multiply it. It still matches this, but not quite as easy. We have log base a to a power. A to a power means we can multiply. Remember, this is an exponent, so we're able to multiply. Again, it doesn't match quite as nicely, but it still is equivalent. Today, we're going to be using this to simplify. This power property is one of the most important properties we're learning today, and it will help us out a ton in the second half of the chapter, as we'll see in a couple weeks. So how are we using it today? Well, if we have something like log base 2 of 16 to the third, well, we could go 16 to the third. Let's see, I know 16 squared is 256. 16 to the third is going to be an even bigger number. And I'm going to have to think of, all right, so 2 to the what power equals that? Or I can move the 3 out in front. 3 times log base 2 of 16. Well, 2 to the what power equals 16? See, we have 2, 4, 8, not 6. How many of you are thinking 6? 2, 4, 8, 16. So that would be 4. So we have 3 times 4, which is 12. Way easier than thinking of, well, let's see, 16 cubed is going to be 2 to the 12th, which is going to be a huge number. So much, much easier. And again, notice it really did not need a calculator to do that problem. And so this is how that one will be used. We have a few more properties that don't match exponential properties. We have a couple inverse properties. The first one, we have log base b of b to the x equals x. Couple ways that we could look at this one. We could think about it logically. B to the what power equals b to the x? B to the what power, b to the blank, equals b to the x? Well, that would be x, b to the x equals b to the x. Another way we could think about this is using this power property we just looked at. We have an exponent. it can move out in front. So you have x times log base b of b. Well, log base b of b, if we remember our special properties from last time, b to the what power equals b, that would be 1. X times 1 is just x, and so it equals x. How could we use this one? We'll be using this and the other one a ton as we're solving equations at the second part of the chapter. Right now, it's basically things like log base 7 of 7 to the 3x plus 1. Well, it's just the exponent. It's just 3x plus 1. That's all it is. The other inverse property is a little bit tougher to wrap your head around. It's b to the log base b of x equals x. Well, b to the log base b. So again, the b's cancel and you're left with this. But how does that work? If we're just looking at the exponent, it says b to the something equals x. And it turns into that something. Then we're asking the question, what does b to the something equal? Well, we just said b to the something equals x. So b to the something equals x. Again, a little bit tougher to kind of conceptualize that one. The other thing you could do is you could rewrite this as a logarithm, which is what we were doing yesterday. Log base b of x equals the exponent, log base b of x. So it works out that way too. How are you going to use it? Things like 5 to log base 5 of 2x squared equals 2x squared. Perhaps we'll throw a 2 here in front of the log, change that into an exponent using the power property, and then do the same thing. So those are the two inverse properties. The last property is going to be the change of base property. Notice that throughout this whole time, all these properties, the base never changed throughout the problem. Nothing that we're going to do in any of this stuff is going to change that base. I always had a base. It could just be the common log, just log of 4, log of 64. It could be any base you want, but they have to be the same. And whatever you're doing is not going to change it. The only thing that's going to change the base is going to be the change of base property. And so the change of base property says if we have log base b of x, it's going to turn into a fraction. We have our new base in both pieces of the fraction. We're going to go log of the new base of x, it's that one, over log to the new base of the old base, b. So we just change it. This will help us be able to simplify some problems that are easy. A few minutes ago, I said that log base 8 of 4 was 2/3. We're going to see why. And it used to be super, super, super important because calculators, and before calculators, we had tables of values. Be thankful we have calculators. But calculators can do 2 logs. They can do this common log, log base 10, and it can do the natural log, which we'll learn about later on in the chapter. Those are the only 2 logs. The calculator is not going to be able to plug in this thing. Yes, on your graphing calculator, there is a way. I'm not going to tell you what that way is because we don't actually need it throughout the chapter. And it's one of the reasons why you won't have a calculator on this test. But it used to be imperative to change everything to base 10. Now there's ways around it, but it's really not that hard. So let's look to see, how did I know that this was 2/3 and this was 4/3? So the first thing is we can look at just the log base 8 of 4, and we can change the base. I'm looking to see 8 and 4. Are those both powers of the same number? And the answer is yes, they are both powers of 2. So I'm going to make my new base 2. Log base 2 of 4, log base 2 of 8. Well, 2 to the what power equals 4? 2. And 2 to the what power equals 8? 3. So that ends up being 2/3. We can do the exact same thing for log base 8 of 16. Log base 2 of 16, log base 2 of 8, this is still 3. 2 to the what power equals 16? That's 4. So we have 4/3. We just need to add 2/3 plus 4/3 together to get 2. So I think it's awesome. Like, it's amazing that it's so consistent. We can do the problem this way and it works. We can do the problem this way and it works. It's the same thing. And that's just one of the reasons why math is so amazing. Try doing that in English and see what happens. So this is one of the times when we'll use a change of base formula to help simplify something that we wouldn't do them both together. We'd probably solve that problem like this. But if we just wanted log base 8 of 4, it equals 2/3. Or if we just want log base 8 of 16, it equals 4/3. This would be two separate problems. The other time is when they don't have that common base. Here, we were able to get a base of 2. But something like log base 4 of 9, well, 4 is 2 to a power, 9 is 3 to a power. We're not going to find a common base there where we're going to be able to simplify. So in this case, we're going to take it to base 10. Just log base 10 of 9 divided by log base 10 of 4. Why would I want to take it to base 10? Because base 10 is what the calculator can do. Scientific calculators can do this. Graphing calculators can do this. All the calculators can do this. And you're going to solve this problem the same way. Now, some calculators, you type log and then the number, like log and then 9. Some calculators, you type 9, then log. It's important to know what your calculator does. Most of them I've seen recently, you're going to type in log and then 9. Pretty much if you put it on the screen, then push enter, it's going to be log then 9. So to do this, I'm going to type log 9 and then enter. It's going to come up with a decimal, point something. And then I'm not going to clear that. I'm not going to bother writing that number down. I don't care what that number is. But I have that number in my answer. I'm going to hit the divided by button. It'll instantly pull that number up. In our graphing calculators, it'll say ANS. It's for the answer. Divided by log 4. Enter. And you end up getting 1.585. So, and the reason I do that in 2 steps is if you go log 9 divided by log 4, it's very possible you're going to get you're going to forget a parenthesis in there, and you're going to do 9 divided by log 4, and then you're going to take the log of that. Doing it in the 2 steps helps with accuracy. But we end up with about 1.585. So these are our log properties that we're going to be using. We've got the product property, quotient property, power property, inverse property, change of base property. All of them we use to simplify logarithms, which would be the first learning target. The change of base property is for the second learning target, where we can write them in whatever base we want. But this is going to be pretty much it for this section. We have a day of this, and we'll have a day of just log practice, which would be this and the last section. And then we're going to review to take our test, which does not have a calculator. So be sure to comment and be ready for a activity in class, and I will see you then.